This is the final video on our conics section. We are talking about parabolas here. So this is actually taking us back to the beginning of the unit. That's why it's 7.1. Parabolas are so much more simple to work with compared to hyperbolas, ellipses, and circles. So right off the bat, there's two standard form equations for parabolas. On the left-hand side, you have parabolas that open vertically, and on the right-hand side, you have parabolas that open up horizontally. Just like ellipses and hyperbolas, parabolas also have a focus, which is located inside the parabola. And then a characteristic that is unique to parabolas is that they also have a directrix, which is located behind the parabola. And then, of course, instead of having a center like circles, ellipses, and hyperbolas, parabolas have a vertex, which is going to be the center at the center of the parabola. And then most importantly, there is a variable known as p, and p is going to be the distance between the focus and the vertex, or the directrix and the vertex. So that should tell you that the vertex is located exactly the same distance from the directrix as it is from the focus. And finally, p can be either positive or negative. The sign determines whether the parabola is oriented up, down, left, or right. So if we pay attention to our table right here, for a parabola that is oriented vertically, if p is if p is greater than 0, which means it's positive, then our parabola opens up. If p is less than 0, which means it's negative, that means our parabola opens down. And then if we have parabolas that are oriented horizontally, if p is greater than 0 or positive, I open to the right. And then if p is less than 0 or negative, I open to the left. Another thing about parabolas that's kind of weird is that we don't really care for standard form. We actually need to know how to write our parabolas in vertex form. And so basically all that means is for a parabola that's oriented vertically, like the equation at the top, we want the equation to be y equals. So we just have to do a little bit of algebra to get us there. If I want the equation to be y equals, I need to get y by itself. So I'm going to go ahead and start by dividing by 4p, or in this situation, I'll just multiply both sides by 1 over 4p. So now I have 1 over 4p times x minus h squared is equal to 1 over 4p times 4p y minus k. So we know here that the 4p's cancel. So now all I'm left with is y minus k. And in order to get rid of this k, I'm going to add k to both sides. So now I have 1 over 4p times x minus h squared plus k is equal to y. So here's the conversion from standard form to vertex form. Now I'm going to go ahead and do the same thing for the horizontal orientation equation, but I'm not going to walk through the math. So I think you should just pause the video and try it on your own before you look at my work. So here is the completed answer for the horizontal orientation. This is standard form. This is vertex form. So now we're going to head into the problems. I will say, just like for hyperbolas, there's no way for me to cover every type of scenario that you can be presented with. So I'm going to do 3 problems that might show up on IXL. Maybe a different type of problem will show up. Basically, you need to look at what you have, what information they give you, and what you can find from that information. So let's start by identifying some helpful information here. My hyperbola is opening up in the horizontal orientation. So we know that this is going to be the standard form equation that I'm going to work off of. Looking at the standard form equation, we know that we need h and k, which of course is given to us by our vertex. And we also need to find p, which of course is going to be the distance between the vertex and the directrix. So I know my vertex is located at 2, 0, which means h is equal to 2 and k is equal to 0. I also know that p is equal to 2 because I simply just counted the distance from my vertex to my directrix, but I have to pay special attention to something. My parabola is opening to the left, and we know when a parabola opens to the left, p has to be negative. So now that I have all the information I need, I can write out my equation in standard form, and then I can convert it into vertex form. So here I'm going to say y minus 0 squared is equal to 4 times negative 2 times x minus 2. So I can drop this 0 because it doesn't really do anything for me. So I'm going to say y squared is equal to negative 8 times x minus 2. Let's start by dividing by 8. So I have negative 1/8 y squared is equal to x minus 2. And then I'm going to end by moving the 2 to the other side. So I'm going to add 2. So I have negative 1/8 y squared plus 2 is equal to x. So here is my equation for a horizontal oriented parabola that opens to the left. Okay, so here we're asked to write an equation of a parabola in vertex form. This parabola that's given to us opens horizontally, and they gave us two features of the parabola. They gave us the vertex, which is located at 2, 0, and they also gave us a point that the parabola passes through. So I'm just going to go ahead and start this problem off by writing out the vertex form for a horizontally oriented parabola, which, as you can recall from earlier slides, is going to be x equals 1 over 4p parentheses y minus k squared plus h. So we already know what h and k is equal to because they gave us the vertex of our parabola. So I can go ahead and plug those in. So x is equal to 1 over 4p y minus 0 squared plus 2. Let's go ahead and drop the 0. So I'll say x is equal to 1 over 4p y squared plus 2. So now the only thing left to find is p. Unfortunately, we don't have the directrix or the focus, so we don't know the distance between the vertex and the focus or the vertex and the directrix. So we can't find p using the graph. The only way we could find p is by plugging in the point that they gave us. So I'm going to take this point right here, and I'm going to plug it into this equation right here, and that's going to allow me to solve for p. So I have negative 16 is equal to 1 over 4p times 12 squared plus 2. So I want to get p all by itself, so let's start by moving things from the right to the left. So of course I'm going to start by subtracting 2. So I have negative 16 minus 2 is equal to 1 over 4p times 12 squared. This gives me negative 18 is equal to 1 over 4p. And if I square 12, that gives me 144. So now let's divide by 144. I have negative 18 over 144 is equal to 1 over 4p. So remember, the best way to solve a problem where your variable is in the denominator of a fraction and you have two fractions set equal to each other is simply by cross multiplying. So this effectively becomes negative 18 times 4p is equal to 144 times 1. The left-hand side is negative 72p is equal to 144. If I divide both sides by 72, so 144 over negative 72, that gives me p is equal to negative 2. Now that I have p, I can come back to my original equation and plug it in. So I have x is equal to 1 over 4 times negative 2, y minus 0 squared plus 2. And then we clean this up. So my final answer is x is equal to 1 over negative 8, y squared plus 2. Here, again, we're asked to write the equation of a parabola in vertex form, and they gave us two pieces of information. They gave us our vertex at 3, negative 10, and they gave us our directrix at y equals negative 7. So to be absolutely honest with y'all, the best way to do these types of problems is plot what they give you in Desmos. So here on my graph, I have located my directrix and I've also located my vertex. Now I can easily tell that I'm creating a parabola that is oriented vertically and it's going to open in the downward direction. I'm also easily able to find P, and I already know what H and K are because they gave me the vertex. So I'm going to start by writing the vertex form of a vertical parabola, which, as we recall from the second slide, is y is equal to 1 over 4p x minus h squared plus k. So we know that h is going to be 3 and k is going to be negative 10 because that's given to us in our vertex. So I have y is equal to 1 over 4p x minus 3 squared plus negative 10. And then we also know what P is, because if we look at our graph, I can see that the vertex is 1, 2, 3 away from the directrix. So I know that P is 3, but you also need to remember that for a parabola that opens in the downward direction, P has to be less than 0, which means it's negative. So P is not just 3, P will be negative 3. So I can also plug that in. I have y is equal to 1 over 4 times negative 3 x minus 3 squared minus 10, of course. And then if we clean this up, I have y is equal to 1 over negative 12 x minus 3 squared minus 10. So again, I highly encourage you to use Desmos when you're solving these problems. Another scenario that you could possibly see, which some people might get confused by, is if they give you the directrix and if they give you the focus. So now when they give you those two pieces of information, you need to realize that P is only the distance between the vertex and one of the other two. So instead of, if they didn't give you the vertex and they gave you directrix and focus, you know that the distance between those two values is going to give you 2 times P. So then you would want to divide that by 2. And then also you would want to find the center, so you would be looking for, you would want to find the vertex, so you would be looking for the midpoint between those two values. So again, whenever you're solving these types of problems, use Desmos, Think about what they gave you, think about what information you need, and then go from there. Okay, so last thing to cover is how to go from just a plain Jane equation to the vertex form of a parabola. So here we have an equation that's given. On the right-hand side, I went ahead and wrote out the steps. They're kind of the same type of steps that you see when you solve for circle, ellipse, or hyperbola. This one's a little bit more simple than those are. So again, we're going to start by moving our squared term to the left and everything else to the right. So since x is squared, I'm going to move all of my x's to the left, and I'm going to move my y term to the right. So I have x squared minus 14x is equal to 2y minus 42. And then the next step is, of course, complete the square. So x is the one that I'm going to complete the square for because that's the only squared term. So that gives me x squared minus 14x plus 49. Because remember, 14 divided by 2 is 7. 7 squared is 49. And this is all equal to 2y minus 42. If I add something to the left, I have to add it to the right. So I'm going to add 49. And then, of course, the next step is to factor the left because we made a perfect square. So the left would become x minus 7 squared is equal to 2y. And then negative 42 plus 49 gives us plus 7. And then finally, I'm going to convert from standard form to vertex form. And the way that we're going to do that here is we want to get the value that's not squared by itself. So in this situation, y is not squared, so y needs to be by itself. So let me first start by factoring out a 2 to get y by itself. So I'm going to do x minus 7 squared is equal to 2y plus 7 over 2. So first I'll start by dividing the entire equation by 2, which gives me 1 over 2x minus 7 squared is equal to y plus 7 over 2. And then I will subtract 7 over 2. So this gives me 1/2 x minus 7 squared minus 7 over 2 is equal to y. So here is my vertex form equation of a parabola that started off with an equation that looked like this. So there are 2 assignments on IXL. One of those assignments is just over parabolas. The other assignment is going to require you to look over your notes for parabolas, hyperbolas, ellipses, and circles because it's just finding standard form equations, and that's about it.